Okay, this problem is somewhat similar to number 10. We have on a map, we know that 1 centimeter equals 12 kilometers, and so we can set that up as a proportion because maps scale proportionally. So 1 centimeter is to 12 kilometers. As now on this map, we see that two towns are actually 6.5 centimeters apart. And notice how it's important to keep in the numerator the centimeters, or the map to the map and reality to the reality. If you would have put 6.5 here in the numerator, that would be wrong. In this one we don't know, but here we can see that, like again, this to get from this numerator to this numerator we multiply by 6.5, and so we're going to do the same thing in that denominator, multiply by 6.5. So 12 times 6.5 equals 78. So the answer is 78 kilometers. So here I've drawn the two cars. We have the real car, which we know is 9 feet long. And we have the model car, which we know is 6 inches long. And this is another kind of problem where in order to get a correct ratio, we need to make sure we're in the same units. So we can change either the car to inches or the model to feet. I guess we'll change the model to feet. So instead of 6 inches, we know that 12 inches is in a foot, so we know this would be half a foot, because two of them would give us 12 inches. And now we can go ahead and do this. So ratio of the length of the car to the model. So the car goes first, so we know it's 9 to 0.5, which you can think of as 9 divided by 0.5. And so typically we don't want decimals in ratios is what's really going on here. And so to clear those out, I'm going to multiply the top and bottom by 2 to turn the numerator into the denominator into no decimal. So 0.5 times 2 is 1. 9 times 2 is 8, so 18 to 1. So this really turns into 18 to 1. So the car itself is 18 times bigger than the model. That's the scale factor. That's how to think of that. So the answer is A. So when engaging things that are similar, I think it's helpful to look at the angles or the vertexes of those angles to see what corresponds. And so here we see that these two congruent angles, S and E, we know those are going to correspond, so I'll draw those in squares because that's the single ticked angle. The double ticked angle is R and D, so maybe we'll put those in circles, so those definitely will correspond. And then we have to go around in the same order. I know there's two right angles, but it's important to know that Q is the right angle closest to the double tick mark. So we'll put a diamond around that, maybe a diamond around that. And then the last remaining one is this, is T. So maybe we'll do like an ellipse, a flat circle. And so those are all the corresponding sides, so now we can check these out. So TQ is the one connecting the two right angles, and BE is not connecting the two right angles, so it's not that. TS is this bottom segment here. That would correspond with BE, but definitely doesn't correspond with CD, so we'll cross that one out. RS is the one connecting the two marked angles here. BC is not connecting the two marked angles, so it's not that one. So QR is the diamond to the circle. CD is the diamond to the circle. So those are the corresponding sides. So it's really just lining up those angles and making sure you're looking at the right pieces. So number 14 here, let's just remind ourselves that that little squiggly line there means similar to. And whenever the quadrilaterals are named with their vertices, those are the corresponding vertices. So if A is written first here, it corresponds with W. So we know that those two are corresponding, A and W. B corresponds with X. C corresponds with Y. And then D corresponds with Z. So now we know, at least we know which ones are corresponding. And we're given that AD is 6 right here. DC is 3. WZ is 59. And we're looking to find YZ. I'll call that X. So the trick in finding the scale factor is finding two corresponding sides. So we have that where there's numbers. So here we have that we know 6 and we know 59. So we know 6 turns into 59. So we have to figure out what 3 turns into. So this is where we can set up our proportion. So 6 over 59, because 6 turns into 59, is going to equal 3 turns into something. Well, we can look at the numerators here, and we can just see that we can just do this by dividing by 2. So we know this one will also be divided by 2. So one way to get the answer is to do 59 divided by 2, which is 29.5, which would give you an answer of B. If you really want to solve this proportion, you can do that too. Then we would do the cross multiply. 59 times 3 equals 6 times x. Divide both sides by 6. X equals 59 times 3 over 6. And if you put that on your calculator, you'll get 29.5 also. B. So this is really two problems into one. So again, when we have two similar figures, we want to try and find two corresponding sides where there are actually numbers, because that'll tell us what to do. So if we see 16 and 12 here, we know that 16 turns into 12 between the two of them. So, actually we could do problem or number 15 first, because if we know that 16 turns into 12, that will give us the scale factor. So 16 divided by 12 is 4 over 3 if we go from this direction. This says what is the scale factor from the left figure to the right figure. Now I'm just looking at, the reason I paused for a second there is I'm looking at the answer key, and I see that we say the scale factor is 4/3. I actually feel like the way this was worded here, from the left to the right figure, I would say the scale factor is actually 3/4, because that's what we do. In order to turn 16 into 12, we have to multiply by this scale factor. So it's the same number, it's just a matter of which way we're going. If we were going from this way to this way, it would be a 4/3 scale factor. So either one of those, I'm just going to call it fine for this. So let's go ahead and set up these proportions. So in order to get x, we'll go ahead and use these two corresponding sides. So 16 relates to 12 as x minus 1 relates to 6. So x minus 1 has to go in the numerator, 6 in the denominator. To make this easy, I'm going to turn that into 4/3 before we start. And then I'm going to cross multiply. 4 times 6 is 24. 3 times x minus 1. Again, parentheses important. Distribute to 3. 24 equals 3x minus 3. Add 3 to both sides. 27 equals 3x. X is going to be 9. And then we'll do the same thing for the y coordinate, or the y side. So here I'm going to use that same linkage. 16 over 12 are those two sides, which I know equals the same as 4/3. And that's just to make my math easier. And then we know that y plus 1 is from this figure, turns into 21. And now we can go ahead and set up and solve. 4 times 21 equals 3 times y plus 1. 4 times 21 is 84. Distribute that 3y plus 3. Subtract 3 from both sides. 81 equals 3y. Y is 27 by dividing both sides by 3. So 9 and 27 would give us choice D. So here it's important to just find which angles are corresponding. In this left one we're given two angles, so 60 and 53. So we know that this one will be 67 because all the angles have to add up to 180. I won't do the math here. And then for the same reason here, angle G also has to be 53. So now we know which ones are corresponding. D goes with G because those are both 53. C goes with F. E goes with H, and let's see which one of these are consistent. So the first one has C going with F, that's good, has D going with H, because of the two middle ones, so that one's not right. This one has C going with F, which is good. E goes with G, no good. This one has C going with F, good. D goes with G, good. E goes with H. That one's going to be our answer. Let's just confirm this one is wrong. E goes with F, which is not right. So that one's it, not it. 16 is C.